Hello everyone, welcome to this video. We are going to talk about data splitting. So when it comes to evaluating performance, we want the model to have good results on new data. Because if your model has good results on the training data, it does not mean it will have good results on new data. Now, this might not seem intuitive at first, but think of it this way. If a student studies, it does not mean the student will get good grades. Maybe the student is bad at studying. Maybe the student is studying the wrong things. Or maybe the student is just brute force memorizing the material. It doesn't actually understand the material that the student is studying. So for new data, I put this in quotes, we need new data that the model does not train on or that the student does not study on, right? So let's divide the data. Training set, used to train the model, update weights, and a test set, our new data used to evaluate the model. I put new in quotes because the test set is not actually new data. We just took the original data, separated it out, and the test set serves as a proxy for new data. So for the test set, never train with the test set. Or in our student example, make sure the student never studies with the test set. Imagine giving students the final exam to study on before the final exam. They could memorize answers without understanding the answers. The final exam now cannot determine if students understand the material. So never train with the test set. If you do, the test set now cannot accurately measure if the model will have good results on new data. For the test set, make sure the test set accurately represents new data. What do I mean by that? For example, if your model determines if a person in an image is dancing, make sure your training set and test set have no shared duplicate images. For example, you're using flawed data with duplicate images. Or if your training set uses images of the same 20 people, for example, you did not want to use more people for budget reasons, make sure your test set uses images of different people. Otherwise, you do not know if your model can accurately determine if a person in an image is dancing or if it simply memorized the same 20 people. Let's talk about bad process. And it's not going to be obvious at first why it's bad, but let me explain. Train model on training set, evaluate on the test set, update model with different hyperparameters. Go back to step one. A hyperparameter might be something like the number of layers, number of perceptrons, the learning rate, etc. We'll go over learning rate later on in the course. So maybe your model does better if it has more layers and less perceptrons or vice versa, as an example. Otherwise, go to step 4. Select model with greatest accuracy on test set. Okay, that's the end of the process. Now, why is this bad? While we did not train directly with the test set, we only used the test set for evaluation. We trained on the training set. Trying different hyperparameters for greatest accuracy on test set is a type of training. So we indirectly trained with the test set. The test set becomes compromised. It becomes dirty, so to speak. So the test set now cannot accurately measure if the model will have good results on new data. Because, as I said, the test set becomes compromised and dirty. So how do we fix this? We're going to split our data into 3 sets with a validation set as well. So training set used to train the model, update the weights. The validation set, also our new data, used to evaluate the model during training. I put new in quotes because, again, it's not new data. We just split it off from the original data. And just like the test set, validation set serves as a proxy for new data. And our test set is used to evaluate the model. So now we have a good process, which is train model on training set, evaluate on the validation set, update model with different hyperparameters, go back to step 1, otherwise go to step 4, select model with greatest accuracy on the validation set, and evaluate on the test set. So I say this is a good process, but there's probably some of you watching this that are thinking, well, wait a second, doesn't the validation set become dirty and compromised? Don't we run into the same issue as before? And the answer is yes. The validation set does become compromised and does become dirty. So the validation set now cannot accurately measure if the model will have good results on new data. So why am I saying this is a good process? That's because since the validation set does eventually become dirty and compromised a bit, think of the validation set as a rough estimate of accuracy. But in this good process, the test set is still clean. It's not compromised. So think of the test set as the final estimate of accuracy, the final exam. You could think of the validation set as like practice exams and the test set as well the final exam because the test set is still clean, so to speak. So let's quickly review things. Training set. Used to train the model, update weights. It's fully visible during training. Validation set is used to evaluate the model during training and slowly becomes compromised and dirty and is partially visible during training. Because the validation set becomes dirty and a little bit compromised, use it as a rough estimate of accuracy. The test set is used to evaluate the model. It's clean, it's invisible, it does not become compromised. So we're going to use it as the final estimate of accuracy on new data. Here, I've given myself a reminder to review this file with all of you. So let's get started. Remember that earlier on in the course, we ran this code for our model. As you can see, we have a train data set and a test data set, but we also need our validation data set. So I take my training data set and split it off to create my validation data set. So I have 3 data sets: train, test, and validation. And just as I mentioned in the slides, we will use the training data to update our weights. We'll use the validation data so that we can evaluate our model during training, like right here. As you can see, during training, our validation accuracy goes from 92% to 97%. And once we're done training for 10 epochs, we're going to get our final test accuracy. So during training, be careful about using the training accuracy because for all we know, our student or model brute force memorize the answers. The validation accuracy is something we want to pay a bit more attention to because it's a rough estimate on accuracy, but it still gets a bit compromised and dirty. But the test accuracy, or I guess the test data set, it's clean. And so we can say on new data, our model will probably get about 97.5% accuracy. Let's finish this video off. Creating training, validation, and test sets is extra work, but let's prevent being misled for model performance on new data from real life. Because as I mentioned earlier on in this video, we do not want to end up in a situation where imagine giving students the final exam to study on before the final exam. They could memorize answers without understanding the answers, and now the final exam now cannot determine if students understand the material. Okay, that's it for this video. Thanks for watching.